Microwave tubes, Klystron amplifiers, first part, series on microwave engineering, lecture number 4.11. Klystron amplifiers are microwave tubes. They provide amplification to signals whose frequencies fall in microwave band. These devices usually employ an electron gun which emits electrons. The emitted electrons are then focused into a beam with the help of a focusing grid and then accelerated to high velocities, high energies with the help of an accelerating grid. Now a beam consisting of electrons traveling at a very high velocities comes into being. This beam is then velocity modulated by the signal which we want to amplify. The velocity modulation ultimately leads to density modulation, converting the beam into bunches. Bunches are high density electron clouds. The bunches ultimately give energy to the signal, amplifying it to higher intensity levels. Klystron amplifiers use two cavities, sometimes more than two also. One cavity called buncher cavity or input cavity. It is there to accept the signal. It is to this cavity the signal which requires to be amplified is given. There is another cavity. It is called catcher cavity or output cavity, and the amplified signal is extracted from this cavity. In between these two cavities, some more cavities may also present. If only two cavities are present, then it is called two-cavity klystron amplifier. If it is more than two, it is called multi-cavity klystron amplifier. In general, klystron amplifiers are categorized as devices with higher levels of performance or performing devices. However, as they employ cavities in their design, they tend to be narrowband devices. This is considered to be a serious shortcoming pertaining to these devices. There exist certain techniques to overcome this shortcoming. Employing stagger-tuned cavities with the structure of the device, it is possible to enhance the bandwidth of the device. In the present session, the focus is on the description of the structural features and also the functioning of two-cavity klystron amplifiers. Now let us move further to the core session. Let us start with a few introductory remarks or statements on klystrons. Klystrons, an important class of microwave sources. They were invented by Varian brothers, Russell and Seigard, at Stanford University in 1939. Two-cavity and multi-cavity klystron amplifiers and reflex klystron oscillators fall under klystron category. These are all categorized as O-type tubes. They are also called velocity modulation tubes. They have very low AM and FM noise levels. It is an advantage, it is a plus point, but the major disadvantage with them is their narrow bandwidth. It is a result of high Q cavities used for electron bunching. Now the focus is on two-cavity klystron amplifiers. The two-cavity klystron is a microwave amplifier. It is capable of amplifying signals that fall in microwave band. It consists of an electron gun focusing and accelerating grids. Electron gun emits electrons. These electrons are then focused into a beam by focusing a grid, and then the electrons are accelerated to high velocities using accelerating grid. The combination of these three gives a beam, an electron beam traveling with very high velocity. In addition, these three, there exist two identical cavities separated by a distance. Input is given to one of these two cavities, and output, amplified version of the input, is taken from the other cavity. These two cavities are separated by a distance. It is called drift space. At the other end, one end starts, or one end begins with electron gun. Other end, there exists a grounded collector plate. The electron gun emits electrons from the surface of its cathode, and then they are focused into a beam. Using a DC accelerating positive voltage V0, the beam is accelerated to high velocities. Out of the two cavities, one is given the input signal and is known as input cavity or buncher cavity with a cavity gap of D, and the other, where output is taken out, is known as output cavity or catcher cavity. Usually these two cavities are identical, and hence grid gap is same, equal to D for both the cavities. The region in between the two cavities is called drift region. Its length is usually indicated by L. It is a field-free space. There exists no field in this region, drift region. The length of the drift region is not arbitrary. It is predetermined on the basis of obtaining maximum possible gain. The electron beam gets velocity modulated while passing through the input cavity. Then it undergoes density modulation. First velocity modulation, then density modulation. Density modulation leads to formation of bunches. It gives amplified energetic signal to catcher cavity to get collected by the grounded metal plate collector. The electron beam is ultimately collected by the collector plate. Note that the only function of collector is to dissipate heat. Now, a point to understand here. Here is a beam, electron beam. The beam is velocity modulated by the signal. The velocity modulation ultimately leads to density modulation, which gives rise to the formation of bunches. The bunches then deliver energetic signal to the output cavity, and it is taken out using a loop. Point is, signal which is weak initially, that is given to the beam at the input cavity. At the input cavity, signal is weak, but the beam is highly energetic. While the beam is traveling towards the output cavity, energy transfer takes place from the beam, from the electron beam into the signal. By the time beam reaches the output cavity, energy transfer to the signal becomes maximum. The length between the cavities, L, it is selected in such a way that maximum possible amount of energy transfer takes place from electron beam to the signal. Now, at the output cavity, we have highly energetic signal, and it is taken out for further processing from the output cavity or catcher cavity using loop. Here is the structure of a two-cavity klystron illustrated. This is electron gun, cathode heating coil emits electrons. They are focused with an electron, and then they are accelerated with certain positive voltage V0. Vg is meant for focusing. Now here we have a highly energetic beam of electrons. We can also notice two cavities. Input is given to one cavity. That cavity is called buncher cavity or input cavity. Amplified input is taken from another cavity, which is called output cavity or catcher cavity. The input signal at the buncher cavity, it appears across the grid gap. and it velocity modulates the beam. The velocity modulated beam, while traveling through the drift space, undergo density modulation, resulting in the formation of bunches, electron bunches. These bunches then deliver energy to the grid gap of the catcher cavity. In fact, bunches carry the signal. Signal is there in the bunches. Bunches delivering energy to grid gap means signal, highly energetic signal is being delivered to the grid gap, which is then taken out with the help of a loop. The bunches now, after crossing the catcher cavity gap, they travel towards the collector where they are accepted by the collector. Now, a few points regarding velocity modulation and density modulation. A uniform electron beam is formed from the cathode emitted divergent electrons using a focusing grid and then accelerated to high velocities by an accelerating voltage. If the initial small velocity is neglected, all the electrons after acceleration acquire same velocity because they are accelerated. All electrons are accelerated by one voltage. If we assume the velocity, initial velocity of the electrons 0, then as accelerating voltage is the same, all the electrons naturally acquire same velocity after acceleration, and with this velocity they enter into the input cavity grid gap. In the grid gap, the electrons encounter a signal voltage, which here is assumed for the sake of simplicity of analysis to be sinusoid of single frequency. Let it be V1 sin omega. Let us designate it as VST, V1 sin omega, single sinusoid. Actually, single sinusoid cannot be a signal because signal means which is capable of carrying information. Single sinusoid cannot carry information. So, single sinusoid cannot be the signal, but we are using single sinusoid as the input signal. Reason is this: actual signal can be decomposed into several sinusoids using Fourier theorem, and the solution or result that we obtain by considering single sinusoid input, that result, that solution, we can extend to find the result of the system for the complete signal using linearity property, using Fourier theorem. So there is certain hidden meaning in considering a single sinusoid as input here. In addition to the simplicity of analysis, the single sinusoid may be assumed a component of the actual signal using linearity and superposition. The results of this analysis can be easily extended to find the response of the system when the input is complete signal. During the transit of electron beam through the grid gap, interaction between electrons and gap voltage results in the variation of the velocity of electron. This is known as velocity modulation. Due to velocity modulation, different electrons enter into the drift space with different velocities. This is the grid. Across the grid, voltage appears, that is VST. We assumed the input as a single sinusoid. Single sinusoid means for some time it is positive, for some time it is negative. During positive half cycle, the electrons get accelerated, they get attracted. See, this is the grid wall. If it is positive, electrons which are entering, they get attracted, so acceleration, they get accelerated. Already they are having certain good amount of velocity. So this positive voltage, they give some more acceleration, so they become more in velocity and also in energy. Also notice, during positive half cycle, different electrons get different amounts of acceleration, because suppose an electron is crossing at this instant, it gets certain amount of acceleration. Okay, now we consider another electron which is crossing when the voltage is at a positive peak. Naturally, the second electron must be getting more acceleration than the previous electron. The point is, the accelerated electrons by the signal, they get different amounts of electrons. All of them don't get same amount of acceleration by the input signal. Now, positive half cycle is followed by negative half cycle. During negative half cycle, the electrons, they experience certain amount of repulsion. It leads to deceleration. So during negative half cycle, electrons are decelerated, their velocities naturally decrease. Of course, the amount of decrease is not the same for all the electrons. Some electrons, let us say, which cross the gap during negative peak voltage, signal voltage, they get accelerated maximum, whereas electrons which cross the gap on either side of the peak, signal peak voltage, they get lesser amounts of deceleration. So different electrons get different amounts of deceleration depending upon the instant at which they cross. So this point is explained here. Different electrons enter into the drift space with different velocities, and as a result, faster electrons catch up the slower ones in their subsequent motion through a field-free drift space. So certain electrons are faster, certain electrons are slower. When they enter into the drift space, when they come out of the puncture cavity gap. But notice, here is a point. Slower electrons enter the drift space early. They enter early. Faster electrons enter later. Because of this difference in entry timings of the slower and faster electrons into the drift space, there exists a chance. In fact, it is a reality that while the electrons are traveling in the drift space, faster electrons catch up the slower electrons. Initially, faster electron may be here, slower electron may be here. Reason is slower electron entered into the drift space early. That's why it travels more distance. Even though it is slow, it entered early. Faster electron, even though it is fast, it entered late. That's why it may be here. It may be lagging behind slower electron. But as it is traveling fast, after traveling some distance, what happens is these two come together. Coming together leads to density modulation. Density modulation gives rise to bunch formation. So initially it is like this electron beam. By the time this beam of electrons reaches the catcher cavity grid, it is like this. Compressed. The beam is compressed into a bunch. This bunch then delivers energy to the cavity. As already mentioned, understanding becomes easy if you accept the fact that bunches are with amplified signal. Bunches carry energetic signal. Bunches carry signal enhanced. Bunches delivering energy to the gap means bunches giving the amplified signal to the grid gap, which is then taken out with current flow. Now, it causes the density of the electrons in the beam to undergo a change along the drift region, leading to density modulation. This density modulation ultimately leads to formation of bunches, thin, dense electron clouds. All the electrons that cross the gap during the gap voltage variation from negative peak to positive peak come together forming a bunch. Hence, velocity modulation of electrons leads to density modulation and then into bunch formation. The bunch formation takes place at the rate of one bunch per cycle. While traveling through the drift space, the bunch becomes more and more dense. The length of the drift region so selected that bunch formation gets completed by the time it reaches the second cavity grid gap. Notice all the electrons that cross the gap during negative peak to positive peak. They only participate in bunch formation. Negative peak to positive peak means exactly one half of a cycle. Therefore, the electrons in the beam that cross the gap from negative to peak to positive peak, they are only participating in amplification process. Other electrons which cross from positive peak to negative peak, they are not involved in the amplification process. Hence, they are called waste electrons. 50% of the electrons in the beam, they participate in amplification, remaining participate in no way in the amplification process, and hence the efficiency of this particular device is not more than 50. In fact, it is quite lesser than 50. The bunch formation can be understood by considering Applegate diagram, which is shown here. This is the gap voltage, single sinusoidal input voltage. The electron that crosses when the gap voltage is at negative peak, we consider this electron. It faces certain amount of deceleration, so its velocity comes down. We call this electron retarded electron. Now consider another electron that crosses the grid gap when grid gap voltage is 0. This one, electron which crosses at t equal to TB. This electron gets neither acceleration or deceleration because gap voltage is 0. So it keep on traveling with its initial velocity with which it entered into the grid gap. We call that electron as unaffected electron. We consider another electron which crossed the gap when gap voltage is positive peak. Here it gets maximum amount of acceleration because gap voltage is positive and peak. So it gets accelerated, its velocity increases. We call this electron as accelerated electron. So first electron is retarded electron, second electron is unaffected electron, third electron is accelerated electron. But notice, retarded electron is the one which entered first into the drift region, then unaffected electron, lastly accelerated electron. By the time accelerated electron entered the drift space, the retarded electron might have traveled a certain amount of distance. Let us say this is retarded electron, whereas this is accelerated electron. Unaffected electron may be somewhere here in between these two. Now the point is, after traveling certain distance, certain amount of time, all these three electrons come over a line. Not only these three electrons, all the electrons that cross in between TA and TC, they all come to be over a line, over a plane. What is the reason? This is slow electron. This is fast electron. Even though it is late, its lateness, it covers up by traveling fast and catching up the slower electron. Same is the case with unaffected electrons. They also travel and reach and catch the slow electron. The result is all the three in a line. Three electrons and all the electrons that cross in between TA and TC. They coming into a line, forming into a bunch is the key in understanding the functioning of the device. The completely formed bunch while crossing the catcher cavity gap delivers most of its energy to the retarding field of the gap. The necessary retarding field in the output resonator can be assumed as induced by previous bunches while passing through the resonator. Out of the several components of the induced field, only the component which opposes the motion of the electron bunch receives energy from the bunch. It then grows itself further large, thus providing more and more retardation to the subsequently arriving bunches. The other components which accelerate bunches in the process lose their energy and ultimately die down. Net result is only the field that retard to bunches exists, that retard the bunches exists and grows in the gap. The energy that is given to the grid gap by crossing bunches taken out using a loop. So the point is this, you consider output cavity. This is output cavity. It is a re-entrant cavity. Now cavity is a resonator. In resonator, there exists several frequencies. Of course, they are sometimes harmonically related, sometimes not in case of cavity structures. Anyway, for the sake of discussion, in this structure, there exist several frequencies. In unexcited state, The amplitudes of these frequencies are small, very small, negligibly small. When excited, their amplitude grows. Now, when a bunch crosses the gap, there are two possibilities regarding the interaction between the bunch and the frequencies that are there. Some frequencies accelerate the bunch. Some frequencies retard the bunch motion. The components which accelerate the bunch, they give energy to the bunch. During the process of giving energy to bunch, these components, they lose energy. Already they are very weak. Giving even that small amount of energy which they are having to the bunch means they get further weakened. Ultimately, they die down. So components which favor the motion of bunch, they simply disappear. Other components which retard the motion of the bunch or which oppose the motion of the bunch, these components, they take energy because of retardation. They extract energy from the bunches. When energy comes into them, they become strong. When they are strong, they become capable of applying more retardation to the bunch or subsequently coming bunches, becoming stronger and stronger. Ultimately, only these components, they get amplified. Only the components which oppose the motion of bunches, which retard the bunch movement, they only get amplified. The cavity is designed such that the components which provide retardation to the bunches, they are components or frequencies of the signal which the device is expected to amplify. Here, a timeline diagram of electrons in two-cavity klystron is shown. The instant at which electrons enter into the buncher cavity gap, that instant is indicated by T naught. The instant when they leave, the gap is indicated by T1. The distance between cavity grid walls, it is always indicated by D. Drift to space, length L is shown here. The instant when electron enters cavity gap of catcher cavity, it is usually indicated by T2. Output cavity gap, the width is indicated by D. These are some of the things which I want to share with you regarding two-cavity klystron amplifier. Some more information. It is given in session 2 and session 3. To recap, the structural features of two-cavity klystron amplifier along with its functioning or working, they are all given here, described here in a very clear, understandable manner. Enough for now. Hope you have a wonderful, a beautiful, a transformative learning experience. See you soon again in another session. Bye bye.